Okay, so in this video we're going to try and derive the quantile function for the Rayleigh distribution. Now in the previous video we found the cumulative distribution function for the Rayleigh distribution to be this formula here, 1 minus e to the negative x squared times beta squared over 2. Now this one here, we had our x for the Rayleigh distribution, that is always greater than 0. And our scale parameter beta, that is also greater than 0. Now for the quantile function, we need the cumulative distribution function to find out what our quantile function is, and we set it up a bit like this. So we have the CDF, cumulative distribution function, to be 1 minus e to the minus x squared beta squared over 2. Now what we do is now we set it up to try and find our quantile function. So our quantile function is QA. So Q stands for my quantile function. You could have a lowercase q if you prefer. And A is for the particular quantile. So A is somewhere between 0 and 1. So for example, the median would be a half. So it would be Q of 0.5. So my A would be 0.5. So how we set it up, using this function here, we have A, which is my particular quantile, so it's my lower quartile. I've just set A to be 0.25. And then we have 1 minus e to the minus. So instead of x squared, which is our random variable, I'll set x to be my quantile function. So now I've got QA squared, scale parameter squared, all over 2. And then what I do here, I try and solve for my QA. So that's my goal here with this function here. And then when I've got that, I have my quantile function, and then we can calculate all the different quantiles. So I've got an exponential term here. So natural log is going to be required in a bit. But first of all, let's get this exponential on its own. So let's bring that over this side and bring the a over this side. So if I take this and bring it over this side, it will then become positive. So then I have e to the minus QA squared, right, beta squared over 2. And then my 1 will stay and my a will come over here to be minus. Okay, now this minus sign in here, if I'm going to take the natural log, I want to try and get rid of that. So I'm going to take the reciprocal of these, then I'm going to try and get rid of this minus sign. But first of all, I'm going to write it without the minus sign. So I've got 1 over e to the QA squared beta squared. So that is the same as that without the minus sign, because that's now on the denominator rather than on my numerator. And then this, I will just write this as 1 minus a over 1. And then when I flip them, all I have to do is just turn them all upside down. So then I will have e to my QA squared beta squared over 2. And this would just be 1 over 1 minus a. That's quite a simple reciprocal. And this one, I could put this as divided by 1, but I can just leave that as it is. It's still the same value. Okay, so now I want to try and get this quantile function out of this exponential. So to do that, I just take the log on both sides. So natural log on both sides. So then that would just cancel out my exponential function. So I could just take that off the board as it is there, and that would just leave everything as you see it there. And then my natural log on this side, that will be as it is there. So that's basically taking the natural log on both sides. So now my quantile function here, I just need to get this beta squared over 2 over to this side, and then we've got the QA on its own. So now I've got my quantile function squared equals, well, if I multiply both sides by 2 and divide by my beta squared, I'll basically have 2 over beta squared, natural log 1 over 1 minus a. Now as a is between 0 and 1, this is going to be legitimate, because as a won't actually be 1, I won't end up with a 1 over 0 situation. So that's going to be fine as that is. So now all I need to do now is take the square root on both sides. So take the square root of that, and square root of that. I'll end up now with my quantile function equals plus or minus square root of 2 over beta squared natural log of 1 over 1 minus a. Okay, now we could perhaps bring this beta squared out. We could also bring the 2 out if we would prefer. That's absolutely fine because this is all multiplied inside. Then the next thing to do is to question this plus or minus sign. Now my quantile function, this here is never going to be negative. So the negative here is not going to be required. So I can take that out. And then what I'm going to do is, just to tidy things up, I'm going to take my 2 over beta squared out and just take the square root of that whole term. So now we're left with my quantile function equals square root of 2 over beta multiplied by the square root of the natural log of 1 over 1 minus a, and that will be my quantile function. So that will be my answer. So basically, if I want my median, so Q of 0.5, I just plug in A to be 0.5 on this side. So square root of 2 over my parameter beta, square root of log of 1 over 1 minus a. Well, if a is a half, 1 minus a half is a half. 1 divided by a half is 2. So then that's the square root of the natural log of 2. So that would be my median. Okay, so that's our quantile function for the Rayleigh distribution.